Hi, today I'm going to go over long division and synthetic division, and I do have 4 examples. Let's get started. When you divide f of x by g of x in polynomials, you get the quotient q of x. And you could rewrite this as f of x equals g of x times q of x. Sometimes you do have a remainder r of x, and you write it this way: f of x over g of x equals q of x plus r of x divided by g of x. Or you could write f of x equal g of x times q of x plus r of x. In a long division, that's how it looks like. To give you a simple example, before I do that, the f of x, the polynomial f of x is the dividend, g of x is the divisor, q of x is the quotient, r of x is the remainder. Here's an example. 7 over 2. In a long division, 7 divided by 2 will give you 3. 3 times 2 equals 6. 7 minus 6 we subtract, we get 1, which is the remainder. How do we write this? 7 over 2 equals 3, which is the answer right here, the quotient, plus 1 out of 2 as a remainder. Or you could multiply all the sides, or left side and right side, all the terms I mean, by 2, and you get 7 equals 2 times 3 plus 1. Here's the first example, which is a long division. I do have 2 examples for long division and 2 examples for synthetic division. To divide this polynomial, 2x cubed minus 7x to the second plus 7x minus 2, by a binomial of the form x minus a, in this case it's x minus 2, we do the following. 2x to the third minus 7x to the second goes inside. That's our f of x, and g of x goes right here. Then what we do, we take the leading term, 2x cubed, we divide it by the leading term, x. Let's do that on the side. And what do we get? 2 and x cubed over x to the first will simplify to 2x to the second. That 2x to the second goes on top of the x to the second term, right here. Then we multiply 2x to the second times x, and we multiply 2x to the second times minus 2. And when we do that, we get 2x to the second times x, that's 2x to the third. 2x to the second times negative 2 will be minus 4x to the second. What do we do next? We sometimes, instead of saying subtract, you could do that. This minus this will be 0, and negative 7x to the second minus negative 4 will change it to plus, or most books will do it as change the signs and use add instead of subtract. This is what I mean. So we change the signs one more time, and we say add. This will cancel, and it always cancels. If it doesn't cancel, there is a mistake right here. So when you change the sign here, we have a plus 4x to the second, and we do have minus 7x to the second. That's negative 3x to the second. Then what do? We bring this down, we bring this down, right there. Now we repeat the process again and again. Now we need to divide, negative 3x to the second plus 7x minus 2 by x minus 2. And that's how we do it. We take the leading term, negative 3x to the second, divided by x on the side. And what we have is the following: negative 3x. Negative 3x goes on top, and we multiply by x, multiply by negative 2. Negative 3x times x is negative 3x to the second. Negative 3x times negative 2 is positive 6x. Again, we change the signs and we add. This will cancel, and that will be a minus 6x. When we add it to 7x, we get just 1x. We'll bring the minus 2 down. We repeat the same process. We take the leading term x into the leading term x right here, and that's just 1. Put the 1 up here, and we multiply 1 times x, multiply 1 times negative 2, and we get the same amount. So if we subtract them or we change the signs and add, we get 0. So that's with the remainder of 0. So what's the answer or the quotient? The answer is, we read it from the top right here. 2x to the second minus 7x minus 3x plus 1, and that goes right here. So the first example is an example that doesn't have extra steps in it. You just follow the process. There is no remainder in this case, in this example, and there is no terms missing here. The second example will do have that. Let's go to the second example. Now, when we divide a fifth degree polynomial by first degree, we should expect a fourth degree. But notice right here that we are missing what? We're missing the x cube term. So we need to add it, and we're missing also the x to the second term. We need to add them. What do I mean by this? If the dividend is missing a term, we use a 0 as a placeholder. So this right here will be written as the following. Notice that I added 0x cubed plus 0x to the second. Now, long division, we use this now. So I could have a placeholder for every single term. It's a longer problem, but it has two things in it compared to example number 1. Missing terms, you put zeros, and what about if the remainder is not 0? How do you write your answer? How do you simplify? Okay, now what do? We take the leading term, x, into the leading term, 3x to the fifth, on the side. What do you get? 3x to the 4 goes on top of 5x to the 4. Then we'll multiply 3x to the 4 times x and 3x to the 4 times 2. We put it right here. 3x to the 4 times x will make it fifth. 3x to the 4th times 2 will be 6x to the 4. Again, you could just subtract, and that will cancel, of course, every single time. And when you subtract here, you get minus x to the 4. Or you could change signs and call it add. So if you do that, as I mentioned, we get minus x to the 4 here. We bring everything down here that we in touch we didn't use down. We repeat the process. Okay, now we are going to divide x, the leading term, by the leading term minus x to the 4. Let's do that on the side, right here. We get minus x to the third. That goes on top of x to the third term, right there. Multiply by x and multiply by 2. Negative x cubed times x is negative x to the 4. Negative x to the third times 2 is negative 2x to the third. Let's subtract them and bring this down. This cancels. When you subtract here, this changes to plus. That's why I have positive 2x to the third. Let's bring this down. Let's do this again. Leading term into leading term, right here. So I have 2x to the second goes on top of 0x to the second. We multiply 2x to the second times x, which is 2x cube. We multiply 2x to the second times 2, which is 4x to the second. Again, we subtract, we get minus 4x to the second, this cancels. Bring this down, we do it again. Excuse me. Now, we take the leading term again into the leading term. We get minus 4x, goes on top right here. Minus 4x times x, minus 4x to the second. And minus 4x times 2 is minus 8x. When we subtract, this changes to plus, so we end up with 9x, and this cancels. Bring the 5 down, and let's do it again. One more time. X into 9x. 9. 9 goes up here. 9 times x. 9x. And 9 times 2, 18. When you subtract, I get 5 minus 18, which is negative 13. So we're done. That is the quotient, and that's the remainder. So the answer to this problem is the following. That's the quotient, minus 13 over x plus 2. Or you could say plus a negative 13 over x plus 2. That should do it. Now let's go to synthetic division. Using synthetic division, we're going to be dividing by x minus a. And when you say x minus a or k, that a goes outside. Right here. Now, to avoid writing a positive 5 or negative 5 and make a mistake, you could do the following. Take x minus 5 to the side, make it equal to 0, add 5 to both sides, so x equals 5. So the 0 of this factor is 5. That's what we put outside right here. Just be careful, because if you start with negative 5, everything is going to be different, and you're going to be getting wrong answers. All the numbers here will be different. So this is critical. Start with 5, the correct number, and move on. Now let's put these numbers inside, the coefficients of our polynomial f of x. 2 goes here, negative 7 goes next, negative 11 goes next, negative 20 goes last. What do you do next? 2 goes down. Then we multiply 2 times 5. Let's do this on the side instead of keep multiplying right here. 2 times 5. This 2 in green, this 5 in red. The answer is 10 when you multiply. Where do you put the 10? Right here. So let's put the 10. Then we add. We add negative 7 and 10. That's a 3. Then we do the process again and again. I'm going to take this 3 times 5. Let's put it on the side. The answer is 15. That goes right here. Then we add. Negative 11 and 15 is 4. Again, we multiply 4 times 5. Let's do that on the side. The answer is 20. 20 goes right here. Then we add. When we add, we get 0. That's our remainder. The remainder is 0. That's why it's separated from these 3 green numbers. Now, how do you write the answer? Well, the answer comes this way. This polynomial divided by x minus 5 will be equal to, take a look at this too, cubic divided by first degree will be second degree, and that represents my second degree. If you start from the right side, that's the constant, that's the first degree, that's the second degree. So we have 2 x to the second, we have 3 x to the first, we have the constant 4. That should do it. Let's take another example. This time we will have a remainder. So dividing 2x to the 4 minus 30x to the second minus 2x minus 1 by the binomial x minus 4. There's two things here. We're going to end up with a remainder. We're going to end up fixing this because it looks like we're missing the third degree. So you need a placeholder, a 0 placeholder. First, let's look at x minus 4. We put 4 on the left right here to be on the safe side. Find the 0 of that. Add 4 to both sides, so x equals 4. That will go here. But let me focus on this 0 because if I miss the 0, my work is not going to be correct. So you got to start right. So we have a 0, x cubed. That says the polynomial will be written this way now. Okay? Next, we talked about the 4. Let's put the 4 outside. Let's put the coefficients inside. 2 goes here. 0, we don't want to miss the 0. Negative 30, negative 2, and negative 1. Same like last example. We're going to bring the 2 down. We're going to multiply 2 times 4. Excuse me. Let's put it on the side. 2 times 4 is 8. Where do you put the 8? Right here. Then we add 0 plus 8, which is 8. We repeat the process. We multiply 8 times 4, which is 32. We put the 32 under the negative 30. We add negative 30 and positive 32 is 2. We repeat 2 times 4, put it on the side. 2 times 4 is 8. We put 8 under negative 2. Add them. That's a 6. Multiply 6 times 4. That is 24. We put the 24 under negative 1. Add them. That's at 23. So, how do we write our answer now? We're done with the steps. 2x to the third. Why? Because we have fourth degree divided by first will give me third degree. Those 4 numbers, starting from the right, that's a constant, that's a first degree, that's a second degree, that's a third degree. Just to let you know that we're not missing anything. So that is important, to keep everything aligned and not miss any term. So 2x to the third plus 8, x to the second plus 2x plus 6, the constant. And now we're going to add the remainder. 23, we are dividing by x minus 4. So we're going to write plus the remainder 23 out of x minus 4. That should do it. Thank you.
Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.